So we had P here, A there, B there, and we've shown that PAB, this angle here, is 63.6. It says D lies on the line through A and B, so it's on here somewhere, such that PAD is equal to PDA. So because D's here somewhere, the angle PAD is the same as the angle PAB. So in other words, we need to make a new isosceles triangle here somewhere. So we want this angle to be 63.6 as well. And it wants us to work out the coordinates of D. Now let's go through what we know. We know that this side is 9, and because it's isosceles, this red side needs to be 9 as well. There's two main strategies for this, and I think I went around it a bit of a strange way, so I don't know if this is going to be useful for you guys, but this is the method that I used to start with. I split this triangle in half to make a right angle because it's isosceles, and I calculated the length of A to D. So if we think about this isosceles triangle, if that's my orange side, red side here is the hypotenuse, and the blue side is half of the length of A to D. We know the angle is 63.6, and we know the length of the red side is 9. So we can find the length of the blue side. That's going to be a cos. Cos of 63.6 is going to equal adjacent, so x over 9. So x is going to be 9 cos 63.6. But we know cos 63.6 was that number from part 2, 36 over 81. We've got it right here. So we don't need the calculator for that. We can just write 36 over 81, or 9 times 36 over 81. 9s are going to cancel. We've got 36 over 9 giving us 4. So the length, half of the length of A to D is 4. So the full length of A to D is 8. Now if you also remember, the length of A to B was 9. So that tells us that A to D is 8/9 of A to B. This length was 8, the whole length was 9, so it's 8/9 of A to B. So if we go back and write down what we had for A to B was 366. So it's going to be 8/9 of 366. 8/9 of 3 is going to be 8/3. 8/9 of 6 is going to be 16/3. So we've got 16/3 for the bottom two. Now we've still not finished. So if you think about what we've got, I'll draw it again down here. We've got this point A, this point D. We know A is 519 as a position vector. So here's A. So from the origin to that, that's 519. And we now also know to get from there to D, we use that A to D vector, the one with the fractions, the one with the thirds. So to get the coordinates for D, we're going to need to do O to A plus A to D. So O to D is D's position vector, which will get us the coordinates for D. So we now need to add on or add up 519 and that fraction from earlier, the 8/3, 16/3, 16/3, which will give us what we need, will give us D's coordinates. So 5 plus 8/3 is 23/3. 1 plus 16/3 is 19/3. And 9 plus 16/3 is 43/3. So D is 23/3, 19/3, 43/3. Very, very difficult question, I think.